Okay. So, like I said, we're having a review session. If you guys have any question, we will start with these. And afterward, I'll go over the material in general with the view of the test and also some exercises and maybe some question will rise there. Okay, so does anyone have any questions to begin with?
Not a particular question, but while doing the last homework, I
Yeah.
trying to remember like all of the different Spock rules, like to check if a series converges or not, like absolutely,
Yeah.
or I just like have not much practice in it, so I'm not sure like which to use and when.
Do you want a particular question to work with or just a review in
Um,
general of the
I
process?
mean, yeah, I mean, from what I understood, the process is always trying to see if it absolutely converges to with the five test, and if it's conditionally convergent, we use one of the others. Just like, for example, I saw that one of the solutions was with the root test, but I didn't remember how to use it. So, yeah.
Uh, so you didn't answer me after all that. Do you have a particular question or do you want me to
I mean, I can send you the okay, so it's
or maybe I can get some exercises, other exercises than the one you got. That's another option.
I'll send you the the one that was confusing to me.
Yeah, yeah. It's usually
Uh,
good to start with something that you try to do yourself. In any case, I'm opening a link with a few exercises. Um, exercises, series. Okay. See your question there, and I'll start with it. It's an interesting one, I think. Um, right on the cusp of what we learned, and I'll explain in a while why. And maybe that's something that confused you. In any case, I'm just starting by saying that exercises in series. So each of these links have something in it. This is Mishpat Riemann. We didn't learn it, so you don't need to click here. But I think most exercises are on this page. And each exercise has a full solution underneath it. So for instance, Thomas, if you can look here, this is a very similar exercise to what you gave me. So that's a nice link. I suggest you go through it. It will help you. And I will go through the general process using this example Thomas gave me. And I'll speak about it. Okay, so the process of deciding whether is that true? Yeah. Whether a series diverge conditionally converge or absolutely converge. So it goes as follows. First step, which I call step 0, if the limit of the sequence of elements to be summed is not 0, then the series diverge. If it is 0, it's meaningless and you move forward, but sometimes the process ends at step 0. Second,
Wait, in our case, what is AN?
the sequence of elements, the whole thing here.
Including the -1 to the n?
Everything. Yeah, everything. But you usually put absolute value, since we've learned that the absolute value tends to 0 if and only if the sequence itself tends to 0. So usually you put the absolute value, it makes it easier to calculate, okay?
Right.
Next, use 5 Spock tests, and I'll remind you which are them. Comparison, limit comparison, root test, ratio test or quotient test, whatever, and the condensation test. Afterwards, if the sequence did not converge yet, then we have basically 3 remaining options. If the series is not absolutely converging, then you might have a Leibniz test, Dirichlet test, and calculation of the partial sums sequence. And so these are basically all the options you might have. And now let's look at the specific example Thomas gave us and see how it goes. Now we'll apply this process with 2 Thomas examples. So, and the example was the sigma from 1 to n to infinity of -1 to the n over 2 to the n times 1 minus cosine of 2 over n to the n. Yes. Okay, great. So first of all, step 0, try to calculate the limit of this sequence of numbers to be summed, meaning an. Meaning an is this entire thing, and we wish to calculate its limit. So -1 to the n is bounded between -1 and 1, and 2 to the n goes to infinity. So this whole thing goes to 0. What about this? Next, cosine 1 minus cosine of 2 to the n goes to 1 minus 1. So it's 1 minus cosine of 0, which is 0. And what about 0 to infinity? Because that's what we have here. What can you say about 0 to infinity? Can anyone?
0.
It's 0, yes. Yes, because this is a number smaller than 1 in absolute value. And when you take a power larger than 1, then it's only decreasing. It becomes smaller. So it's even smaller than the original value. So it's 0. In any case, an tends to 0. And if you follow the story, it basically means nothing, right? Because if the limit was not 0 or it didn't have any limit, then we know the series diverge. Since it's 0, it basically tells me it could be anything, any of the options. That's why I call this step 0, because 90% of the time it does not help us too much. We get that the limit is 0. The value of the elements that we are summing up is very small, which makes sense. But the question is whether it's goes to 0 fast enough so the sum will converge, or goes to 0 slow enough so the sum diverge. And that's the whole thing about series. Okay, so step 1 is done. Any question up until now?
Yeah, can you go back to 2C?
Yes.
Okay, thanks.
That's directly by the definition. We did that with the first couple of series. Mostly the geometric series was handled this way. We calculated the sum of a geometric sequence, and that's how we calculated the series itself. Okay. So now we have this. Step one. I didn't write it in the process. Use 5-spoke test for the series, of absolute values. Okay, I want to make it more clear. I use the test on the absolute values because all these tests are for positive series. So I remembered it now because that's what I was about to do, to put the absolute values and then study the series. So we study the series of absolute values. Okay. So first of all, the -1 to the power of n goes. Second, since cosine is always, remember that cosine of anything is always smaller or equal to 1. Thus, the whole thing is 1 minus cosine 2 over n to the power of n over 2 to the power of n. Okay. And now we need to think on our next step. So the options are comparison tests, and I'll remind you of the test. I'll write it. Visual and it's not summation. It's a סיכום.
Summary.
Summary. The visual summary of the test or tests. The conversion tests, not conversion. Convergence tests. Okay. So, just a second, I'll do it with my hand. Okay, that's that. And I need a place for the condensation test as well. So I'll start with the condensation. Condensations say that an is the same as 2 to the power of n, a to the 2n. There are assumptions needed to use this test, but this is just a summary, not the full theorem. So that's the condensation test. Just looking at it, instead of n, we will write 2 to the power of n. To me, that looks kind of awful. I wouldn't do it here. But that's what you need to think. Instead of n, putting 2 to the n and multiplying by 2 to the n. Again, here it will be awful because the n itself, you might be tempted because you say, if I multiply by 2 to the n, then it cancels out. But no, you multiply by 2 to the n, but here it doesn't remain n. It becomes 2 to the n. So it will be 2 to the 2 to the n, something horrible and not helpful at all. And next, we have the comparison test, which is basically trying to see whether it is smaller or bigger than some known series. And what are our known series? We have 1 over n to the alpha, and we also have the geometric series. The limit comparison, I'm taking the limit I have over the sequence of element of the series that I know, and I calculate the limit. Here, I'm not too thrilled. I'll delete. I wrote just this series because it could be something general. So right here, b to the n. And here I'm checking the limit. And next we have the root test, which looks like this. And the ratio test, which looks like this. And you need to calculate these limits. So that's a visual summary of our options. And next, we need to choose one of these options. Thomas, do you know already the answer?
Yeah.
Okay, so
not
wait,
to say.
yeah, not to say it. Maybe someone else wants to give it a go. Because for me, I will tell you, it's rather clear, and I want to explain why I find this clear. Sammy, do you care to give it a go?
I think I already know the answer. This question was from our homework, right?
Yeah. So you
Yeah.
solved it as well?
Yeah.
Okay,
Although
so
it took me a while, even though it's so like now I see it and it's so obvious, it took me so long to realize what the right one was. I don't know why.
Yes.
I did it like 3 times over, and then like I took a break and I was in a class. I can't even remember. I was in just a random class and I was looking at this in another random class and I just saw it and I was like, obviously it's that one. Like why did I not realize sooner?
Yeah. So I'll tell you. So condensation is not that, and the ratio test is also horrible. All three other tests will work. But what for me should be shout loudest is the fact that you see here the geometric sequence. You see 1 over 2 to the n, which is a known series, and the numerator is bounded, so it's smaller than a converging series. So that would be the easiest answer for me, the first comparison test. So this is smaller than just 1 over 2 to the n, which is half to the n, since the geometric series sigma half to the n converge, then so is our smaller series. And remember, I didn't write it. I'll write it here next to the process and the known sequence series you need to know. Known series. So the first one is the geometric one, sigma from n equals 0 to infinity, x to the n, and we even know its value. It's 1 over 1 minus x, and the geometric series converge if and only if the absolute value of x is smaller than 1. And in our case here, we used it where x is half. Just a second. And so that's silly that I ordered the page, but now I'm going to add more text above. Second, the generalized harmonic series converge if and only if p is larger than 1, where the general harmonic series is sum from n equals 1 to infinity, 1 over n to the p. So these are your go-to examples. These two any student must know by heart. And I can't imagine any test not using at least one of them, usually both of them, okay? When I say test, I mean exam. There are examples that don't use these two, but any exam with a few exercises always use these two. You must have them by heart. And you see why. Because when I looked at the series, right now I need to think. Okay. And just a second here. Right. When I looked at the series, I saw the geometric one. If I don't know the series we have, then I might miss stuff like that. Okay. So the final answer here, since the series, it's not sense. Therefore, the series is absolutely converging, and we are done. That's the answer for that question. Any questions so far?
Yeah, in this case, what I found was that we could use the root test, but what you did was
As well.
easy.
As well, the root test, if you take the root test, the n cancels out. The numerator tends to 0/2, so you have 0, which is smaller than 1. I don't think what I did is easier. What I did, I think, is more natural since we see it, but it doesn't really matter because in the exam you don't always see what's so-called natural. You have to be able to try the test and see what works for you. That's the work that needs to be done in these kind of questions.
Do you have any particular question in mind in which you should use the root test? And you
No, the whole thing, I think, Thomas, in this type of question is that you don't know ahead what is the correct test. Sometimes in the test we even send you on the wrong track, right? Like sometimes students say, when you see log, it's always condensation. So we just plug in log to see if you're working like a robot or thinking. But the whole thing is to have enough control of the test, knowledge of the test, so you will be able to try few of them until you find the correct one. That's the main thing usually about these type of questions. I'll remind everyone who don't remember or did not start solving exercise as I pleaded you to. Tests, I mean, not exercise. Let's look at some tests. This one, is it good? Is it not good? We'll see in a second. Yes, this is the perfect example. Remember, this is the structure of the exam. Explain it. First question, first of all, it's 5 questions, 22 points each. Altogether, it's 110. Instead of choice, you can solve as much as you can. And worst case, you pass 100 and you'll get 100. I don't think it's usually not a big problem. First question of 22 points is 3 limits. The third one is always a sequence. The first 2 are functions. Sadly, we are not exactly yet there because it relies the first limit always has to do with limits that we are studying now, like sine of x over x and a few more. We'll finish that in the next lesson, I think. The second one, usually, not always, use L'Hopital. And the third one, you should be able to solve most of them. Okay? So that's the first question. The second question is just what we did now. Okay, that's the series converging, absolutely converging, and whatnot. The third question is about monotonic sequences. So 1, 2, and 3 are the technical questions. Altogether, it's 66 points. I would assume that whoever is really on top of things gets usually between 40 and 50 points in average in all of these. And then you have two more questions. You need to altogether get another 20 points to pass the exam. And if you want to excel, then that's a bit harder. But these are the more theoretic type questions slash function analysis questions. Okay, but what I'm saying is for the first part, and I suggest you do it in the upcoming days, you need to be able to solve 1, 2, and 3. When 1 is a bit of a problem still, you can do the third one in 1. You can try to read the solutions for 1A. And I have many questions of the type 1 and 3. Why? Because in the Math Wiki, when we go to engineering tests, they have not the same material as you guys, but some questions are the same. But they have many tests because this class I've taught for years. So questions number 1 and 5 from these exams are most relevant to you. There are a few questions more there that are relevant, but for now, these are the one I'm pointing out, singling out. So look, question number 1 is the same structure. Question number 5 is the same structure. Question number 4 is like the theoretical one, and 3 and 4. Let me write it all together. 3 and 4 are like are similar to questions 4 and 5 in your exam. So, but that's for later. We didn't study this material yet. Okay, but 1 and 5, we're almost there. And in any case, there are more than 40 exams here, all of which, until maybe the last ones, have full solutions. So even questions number 1 that uses L'Hopital rule or some known limits, like here, you see sine of x over x when x goes to 0 is 1. We learned that. This limit over here, we've also learned, but we did not emphasize enough yet. But if you read a few solutions, you will get it by the 5th one out of the 40, right? And these use L'Hopital sometimes, so it might be a bit more tricky. But I do suggest you start doing it. It may promise you a good grade, just doing the work, right? Other than studying, which is important, this is actually work you can do. Solve exercises, read a solution, solve, read, and so forth. I highly recommend that. Okay. But they don't have series in that course. That's the missing part. But I did give you links to work with series, like I said here. Any questions? Next. That's it, Thomas, because you said you had a lot of
Like, yeah, from the last homework, it's just most
no,
of
because you wanted to meet with me tomorrow, but that's
ah
won't happen.
I mean, yeah, no, the day after
Or it's
tomorrow.
for linear.
Yeah, 1 second,
Because
I'll open that.
tomorrow will be the same as today. I will also do review. So in both subjects.
Okay.
Next week, if the war will continue, we'll keep studying the material. But today and tomorrow, I feel not tomorrow. I mean Tuesday. Sorry.
Mm.
But this week, I think I will do. For you, I will do just review, and I'm not sure what to do about my classes in Thursday, but that's none of your concern. Okay. Um, okay. In linear on Tuesday, definitely a review. In calculus, we'll see how things go and if we'll start getting good night sleeps before or not. I was actually a bit surprised that the university said, okay, just teach by Zoom as if everything is normal.
Yeah, a lot of students were saying we shouldn't show up to any lectures because the university was asking professors to take assistants, but for computer science we don't take assistants anyway, so there's no change.
Hmm.
Um, for linear, I mean, the
No,
last
it's not
couple of
now. No. So linear, let's keep it Tuesday. It's okay
okay,
if you don't have any questions now. Uh, so what we'll do next, I do have a plan, flexible one. I've shown you the structure of the test. I've
mhm.
closed any of them, and wait, I'm trying to figure. Oh, here. Um, and you guys choose. Okay, I even narrowed the choice between 2 and 3. Which type of question do you want to do? Stuff like 2 or stuff like 3? Like series or monotonic sequences? What do you prefer?
What's in monotonic sequences again? Sorry, monotonic.
3. These type of questions. Recursive sequences.
Yeah,
Oh, can we do two instead? Because three is relatively like
So why do you say 2? The series?
yeah, because two there's so many different options for like different tests we could do, and so that like we
Yeah,
in order to answer
and
the
don't
questions
even have
we
to.
need to have an intuition which only takes like doing more questions, whereas three is
It's
relatively
all,
standard, like you just do the same thing over and over again.
Sammy, it's not that one of the question is harder than the other. It's only a matter of what you exercise already and what you need more exercise at. They all have their own technical I don't know, geshim, uh, emphasize points. That's horrible. They all have these things you need to know, the important things you need to know. But after you exercise them, you will be good. So my question is basically, right now, what do you wish to do? So you chosen 2, and let's do 2, but not specifically the question here. I'll try to get questions that will be a bit harder for you to choose out of the tests, and it will be more helpful, I think. I don't think that's hard to choose. There are a few tests here where are not structured, and then I need to search and know what is relevant. Let's see. Okay, I think that's a nice question. I'll translate it. So English. So we have the sequence an equals n to the power of 4a times ln log of n cubed plus 5 minus 3 times the log n, where a is a positive constant. Okay, so the first question is, write all of the possible limits of that sequence. So what does it mean? Since we have a constant a, which is a parameter, for different values of a, you may get different answers to the limit of an. So they're asking you, what possible results could there be? While it is not a question supposedly directly in series, it is step 0, right? Step 0 say, if we were to look to study the series of these numbers, the infinite sum of them all, we would first look at the limit of the elements themselves. So yes, so we start with studying the limits. Okay. And so what can you say about n to the power of 4a? What would be the limit of that?
Infinity.
What?
Infinity.
Infinity, yeah, because it's infinity in the power of a positive, which is infinity. Okay, so that's just the infinity here. What do we have here? Let's look at that.
Yeah.
Yeah, I'll let you speak in a second. Yes, Thomas. What do
So
you want to say?
what I'm thinking is, because of logarithm math, we can put the 3 inside of the log n. So it's a log of n to the third power.
Wait a second, you're correct. But first, I just wish for you to notice it's infinity minus infinity. Do you agree?
Mm,
So
yeah.
starting to do algebraic tricks is to solve some problems. So this is the problem we have. It's infinity minus infinity. And now I'll do exactly as you said. That's the limit of log of n cubed plus 5 minus the log of n cubed. What next?
Because it's a logarithm minus a logarithm, we can divide the inside of the logarithm.
Yeah, it's the log of n cubed plus 5 over n cubed. Agreed? Which is the limit of the log of 1 plus 5 over n cubed. Great. What can you say about that? First of all, well, not first of all. What can you say about that? This limit.
it goes to 1.
Yes.
Yeah, and it's e to the
Log
0.
of 1 is 0. Agreed? So now if we look at the whole thing, this goes to infinity together. I like this exercise because it exercises also other things. And together, this goes to infinity times 0, which is another problematic case. Who knows what can we do next? You're muted, Thomas.
No, I'm thinking I thought
Okay.
like not Dirichlet's Leibniz, but no, we can do one of the other
No,
tests.
you're confused. It's not series yet. It's
Okay.
just a limit. It's just a limit. What is the limit even? It's infinity times 0. What can we do with that? Any ideas yet?
I mean, we said infinity times 0 is 0, no?
No, we did not say such thing at all. Because it's false. And
Right.
times
Sorry,
1
yeah.
over n, right? So we need to use the algebraic tricks we just did. An is n to the power of 4a times this log. Right? Because these were all algebraic tricks we did over at this part. And we got to this. So
Okay.
what will be the next step?
We put the n to the 4th power a inside.
Yeah. So it's a log of 1 plus 5 over n cubed to the power of 4a, sorry, n to the 4a.
And now we are trying to find the limit, so we can use the trick to say e to the power of n
Oh.
for a times 5 over n3.
Yeah, I'm proud of you for not saying
That I have never seen it before.
life. Yes, and a bit מאוכזב. Forgot disappointed. Okay. So this expression is of the type, since this goes to 1, we're allowed to use the E rule. This tends to it's better with parenthesis. So this goes to 1. So we can use the E rule, which says it's e to the power of the limit of n to the 4a times 5 over n cubed, because it's the power times the base minus 1. The minus 1 cancels the 1, and that's what we're left with. Okay. Which is e to the power of the limit of 5 times n to the power of 4a minus 3. Almost done. What can you say about this limit here?
It depends on a.
How so? Yeah, you're correct. How so?
If a is
If 4a equals 3, right?
yeah, equals this equals 1.
The limit is e to the 0, which is 1. Therefore,
or 0.
an tends to log of 1, which is 0, right? Because an is the log of the limit here. And if the limit here is 1, then log of 1 is 0. Something does not.
That's not right.
Yeah,
That's
yeah,
not right.
yeah. I was sorry.
It's n to
Sorry,
the
I was
0.
messed up. It's 5. It's 5. Look at it. It didn't make sense. It's 5 because 5 times 1. The power here is 0. N to the 0 is 1, so the limit is 5, so it's e to the 5. And
No, the limit isn't e to the 5. You're missing out the ln as well.
Yeah, he's writing it in the bottom. Okay.
Yeah,
So-
no. The limit here is e to the 5.
Oh, sorry, yes.
Put it into the log. Log of e to the 5 is simply 5.
Sorry, I
So
didn't
the
see the last
limit
line.
is 5, sorry. Okay? So if a is 3/4, the limit is 5. Agreed?
Mhm.
What other cases do we care about?
Both inequalities. For a is bigger than 3 and for a is less than 3.
Yeah, positive or negative. If 4a is larger than 3, meaning i.e. a is larger than 3/4, then we have e to the power of infinity, right? Because that's infinity in a positive, which is infinity. And log of infinity is also infinity. So an goes to infinity altogether. Agreed? Lastly, if 4a is smaller than 3, then we have n to a negative value, infinity, or a minus 3. So we have infinity to the power of a negative, negative. And what's infinity to the power of a negative? It's 0. So here you have n tends to the log of e to the 0, which is 0. So these are the 3 options. I'll do a summary. If a equals 3/4, then an goes to 5. If a is larger than 3/4, then an goes to infinity. If a is smaller than 3/4, then an goes to 0. Now I'm just wondering, and I will check with you guys, whether ChatGPT would know this. I have a hunch that it would, but let's quickly check. That looks good. That's a trick, but it's true. Yeah, 0, 5, infinity, smaller, equal, or larger than 3/4. Yeah, impressive. Okay, so this is the answer to the first part of the question. Now we're off to the second one. Find a value of the parameter for which the series is conditionally converging. If no such value exists, prove it. Okay? And this is the series. It's -1 to the power of n times an. So first of all, for which values is there any chance for the series to converge? Has everyone left the building?
Sorry, was answering my mother.
Yes.
What? Sorry
So
again.
my question was, we need to find a value of the parameter for which this series is conditionally converging. If no such value exists, I need to prove it. And my specific question was, first question is, for which values of the parameter is there even a chance that this series converge?
When a goes to 0, this is Leibniz now.
When an goes to 0, not just because of Leibniz. What happens if the parameter a, is equal to 3/4 or larger than 3/4?
So it doesn't go to 0.
Yeah, and that's why the series converge. So I'll write the question and then I'll write what I said up until now. Part 2, section 2. Find a value of a such that -1 to the power of n. כרמלי, השאירו לך פה משהו. השאירו לך משהו בחצר. is conditionally, לא יודע, מישהו היה פה. Converging, and if no such value exists, prove it. That's the question. That's just a translation. And then what did we say? If A is larger or equal to 3/4, then the sequence of elements to be summed does not tend to 0. And therefore, the above theories diverge. So we have nothing to look for at this part. We need to look at A's smaller than 3/4. Actually, just to remind myself, A is positive. So it's between 0 and 3/4. So we need to look at A's between 0 and 3/4 and somehow know what to do with the sequence. But I strongly urge you to use the value after the algebraic simplification. One might argue whether it's a simplification or a complication, but I think it will be easier to work with in this form rather than the original one. So assume A is between 0 and 3/4 and study the series sigma 1 to infinity. There is no R in infinity. Of -1 to the power of n times this. Okay, so this is the series we're working with, and the question is whether it's conditionally, it's a question of series, whether it's absolutely converging, conditionally converging, and whatnot. And does anyone have any guess as to what to do next? And I'll give you a hint. I don't know the answer. Wait before Thomas, you say, I just wish to give you some pointers. I don't know the answer, but from the question, when they say, please find one value, usually trying to solve the whole thing, meaning to say for each value of A, what happens might be too long or even impossible. So what I would have done as a student in such an exercise is try to pick a few values and hope for the best. But it doesn't have to be the smart thing to do. Yes, Thomas, do you have any suggestions?
We can pick a random value for A between 0 and 3/4 and show that it's monotonically decreasing.
But it's not enough. Leibniz says converging. It does not say that it's conditionally converging. In order to prove that it's conditionally converging, we must prove that it's not absolutely converging. Okay?
You mean that
And
if it's conditionally converging, it's not okay? So
it's not conditionally. Note, if sigma an is converging, it's not necessarily conditionally converging. Look at the following example, Thomas. If you have -1 to the n over n squared is converging absolutely, not conditionally, because the absolute value also converge. So just proving that this is monotonically decreasing to 0 says the series converge. It doesn't mean it's conditionally converge. That's the point.
so the question is find if it's absolutely or conditionally?
Or nothing. But specifically, they wanted conditionally.
Okay.
So you must prove that it converge and the absolute values diverge. You need to prove two things here. I'm thinking I'm taking the time here thinking whether I should solve it in general for any A or pick a specific A like I suggested before. I'm not sure because I don't see the answer through the end, to be honest.
I think that you should do 3/4, like the max value for A, which we think will converge.
No, but we know when A is 3/4, the limit here is 5, and it's diverge. It diverge. We know that it's diverge when A actually equals 3/4. Only when A is smaller than 3/4 does this goes to 1 and the log goes to 0. Let's pick a value. I don't see any other options. What is smaller than 3/4?
1/2.
2/4.
Yeah.
Yeah, exactly. That's right. I honestly don't know the answer ahead. I'm solving it together with you guys. Try to choose A equals 2/4, which is a half, which is smaller than 3/4 and larger than 0. In this case, we have the series. We have the series, and here instead of 4A, it's just 2. So that's the series. And we will try to check if this series is absolutely converging.
Why are we choosing a random value?
What, Sammy?
Why are we just choosing a random value rather than
Because
putting
it's
it down?
easier than solving the general case, I think. I'm not sure. We could have possibly tried to solve the general case, but I said a hint in the question itself. The question says find a value. So if you will find one, that's enough. So that's another reason I'm doing it. But I'm not sure it's the right course to go, as I am not sure what is the answer to the question. Okay, I'm solving it together with you guys, and hopefully we'll be smarter after we'll do that. That's why I'm saying try to. I'm not, this is what I have to do, right? That's the way you go to mathematical question. You try a few stuff, and then you get an educated guess, and then you can prove your answer, okay? And sometimes I like to go with a parameter until the end when it is easy enough. Here it seems to me a bit confusing, but I could be mistaken. It could be on the same level of difficulty. I'm not sure. Okay, so the absolute values of the sequence to be summed are log of this. Let me just make sure of it. The absolute value obviously does not have -1 to the n, because the absolute value of -1 to the n is 1. The question remains whether this is positive or negative. Is it bigger than 1? Oh, it's obviously bigger than 1. This is bigger than 1, the base here, in a positive, so this is bigger than 1, that's fine. So these are the absolute values. Now I go over to the 5 Spock tests, and I need to choose one of them to work with. Which one seems best fitting?
Sorry, what are we up to now? I got distracted for a second.
This is the series we wish to study. Just a second. Just a second, I'll try to copy it without. Oh, wait. Okay. This is the series we wish to study, whether it's absolutely converging or not. And I'm asking, what of the 5 Spock tests should we try as to decide whether this is converging or not? And I've shown you the 5 tests. It's either condensation test, which looks horrible here. The root test, it's the root of the log. It's not good. Also the ratio test. It's either comparison or limit comparison. I think these are the only two.
Can we take the n squared from inside the logarithm and use as 1 times n squared?
Take the n squared out.
Yeah.
You did give me a very good idea as to
This is
see in my head one step forward, but I
this.
wish
I
to
don't think this works. I don't think this works.
I wish to I wish to show you what to do when you have no idea what to do. Okay, if we have no clue as for the next step, we can always try a limit comparison with the harmonic series or the general harmonic series. So it's really important that we had this discussion together. As you see, even I don't know if even, but I didn't see straight ahead what is the next step until Thomas, you said something and it helped me see the next step. But even if I didn't, I was about to do the very next thing anyway, is to do the comparison with the harmonic. So I'll do it without so-called seeing the next step. How do we do comparison test? We take the sequence we have, we divide by the harmonic sequence, and we calculate the limit, right? That's the limit comparison. That's the second test in the 5 Spock tests, right? You take the series you have, you divide by a series you know, and you find the limit in order to compare the two.
Sorry, in this case, you chose the harmonic because you're trying to show that it diverges?
I'm not trying, no. So this is important, Thomas. That's exactly what I'm saying. I'm not trying to show anything because assume I have no idea what's going on. Okay? I'm trying to see whether it compares to 1 over n. Using the calculation, I will see whether it's above it, below it, or actually they are BFFs, like I said in class, and they are equivalent. Okay, but I'm not trying to show anything. I'm just trying to do any kind of comparison because I have no idea. So now I have a limit problem. Does anyone have any guesses as to how to calculate these limits?
Is it what I said before?
I think so, but say it again.
We take out n squared, so we can cancel out with 1 over n.
Not exactly. That's what gave me the idea, but I'm going to do the opposite. I'm going to take, that's n times the log of this. Agreed?
Mm-hmm.
Which is what can we do with n?
Just multiply it by n squared inside.
Yeah, so we have the log of n cubed here. Agreed? That's
Mhm.
what I saw when you suggested to take out the n squared, and then I realized that's really the good track. Why? Where does this tends to? That's almost an obvious limit.
To e
E to the
overall.
5.
Yeah. Okay.
E to the 5. So in a test, you need to elaborate on that. But for now, I'll do it quickly because we did stuff like that before. So the entire limit, what is it?
1,
5,
5. Sorry. Yeah.
right? What does it mean that the limit ended up being 5?
That it's not absolutely convergent.
Yeah, but why? Our series is BFF with the harmonic series. And since the harmonic series diverge, so is the series of absolute values. So our original series at a equals half does not absolutely converge. If it converge, we are done. Then that's enough. If the series converge and not absolutely converge, then it's conditionally converge, and that's exactly what we were looking for. So I think it was a good idea to choose an A, and we chose the right one because we got exactly the BFF of 1 over n. That's exactly why I did that. If it was with general A, it would be a bit more confusing, but we had a bit of luck. Okay, so does that pass the Leibniz test? So in order for the series to converge, we need to show that we don't need to. It is enough to show that log of 1 plus 5 over n cubed times n squared is monotonic decreasing. Since we already know it tends to 0, and then if so, the sigma of -1 to the n times something monotonic that goes to 0 by Leibniz test, it's converging. Converge. So all we need to say is that this thing is monotonic. And since the log function is increasing as a function, it is enough to show that this thing is decreasing. is decreasing. Okay, if that is decreasing, we've solved the question. I'm sure it's decreasing. The main question is how the hell to show it. Because if you remember, proving that these kind of sequences, the sequence that tends to E, to show that it was monotonic was rather difficult. And sometimes when I see a question like this, these in test, I didn't write the test. Whose test is it? It's not that. Sometimes I think that they didn't actually wish the students will show it all the way through. Excise me, but I don't believe that I solved it. I think it's 2021. I think it was Corona and they were tested at home. So sometimes we did stuff more complicated as to ask them afterwards, how did you solve it, to make sure they didn't copy their answers. Three is definitely my question, but two, I don't think so. So in any case, we need to figure out how to prove this is decreasing. And did you want to say anything, Thomas?
Can you try to do the ratio between the logarithms of like n and n+1 to make it easier?
Why do I need the logarithm?
Because you're trying to find the difference between two sequences which are to the power of something that you don't fully comprehend because it's n squared and +1 squared. So if you do the logarithm, you can take n and n+1 out, and the ratio between n and n+1 works. No?
I don't think so, because the ratio between them will work, but it will be 1. It's not helpful. You need smaller than 1 or bigger than 1. The ratio will tend to 1. I'm pretty sure. So I don't think that's helpful. Let me think for a second. And let's write, what do we need to prove? You know what? Okay, let's do something. We didn't study it yet in class, but that's something we might, by the exam, we are allowed to do. Study the function f of x, which is 1 plus 5 over x cubed to the power of x squared. If this function is decreasing, then we are done. Because if the function is decreasing in general, it decreases over the natural numbers. And how do I know? Why did I go to the function? How can I tell if a function is decreasing?
By deriving it.
Yeah, exactly. And moreover, if
Twice,
this function,
deriving it twice.
no, yeah, once. If this function is decreasing, even starting from some value, then we are done. Okay, because even if it will start decreasing by x equal 1,000, okay, so after n is 1,000, then it start decreasing, but a finite amount of elements does not change the convergence of the series. So we can use it, do it using the derivative. We didn't learn yet how to derive such a thing. I'm just wondering if it works, so I'll pop it into GeoGebra to have the answer. And later on in the course, we'll study how to calculate it. Graphing. So it is 1 over 5 over x cubed to the power of x squared. And you actually see, yes, it started decreasing at 2, just before 2, right? But it does decrease, sorry. So if you remind me when we get to this subject, I will calculate the derivative of this function. We will learn in the future how to derive this type of function. Near future. Well, the semester is almost over anyway, but we will learn in the near future how to derive such a function and then find out, yeah, it's actually decreasing, the derivative is negative, and that will finish the 12-point section of this question. Any questions? So
I'm just thinking there's really no good way of doing this, like of doing the difference, right? Because like
what difference?
To check if it's monotonically decreasing, because
No, because that's exactly like it, Thomas. We had a whole session just talking about the sequence and the averages theorem, inequality. So doing it algebraically is possibly possible, but I don't think that's what was asked of the students, um, expected of the students, not asked.
So we wouldn't have
To
to prove that it's
analyze, wait a second, Sammy. To analyze the function, it's definitely something the students should be able to do. Because I didn't derive it yet, I'm not sure if anything algebraic will get complicated next, but I think it should be fine. I think it should be fine. Okay, but doing it algebraically for the difference between an plus 1 and an, that's too hard. That's too hard. That's definitely not the way.
Okay.
So, in some sense, this is a very hard questions, but in other sense, it's a very good question because it shows you a wide variety as to what we do. I'm leaving you for homework to find the next, to solve the next section. Say, is there any value of A for which it's absolutely converging? Which A would you try?
Anything over
Luckily,
1/2.
yeah, either over 1/2 or below 1/2, because 1/2 got us straight to 1/n. So yeah, I completely agree that anything over or anything under might do the trick. So try for homework doing that, and that's enough for today.
Do
And
you want to try and put it in AI, the last question, to see if it finds how to do it without derivatives?
yeah, let's give everything to the AI. Let's do a couple of minutes more and see.
Okay, got that part.
Yeah, wait, just write it in English. Part B, Find values. Say if it's lower than half, then it's absolutely converging. But how does it know that? He used. Oh, I used that. Oh, I see. Oh, it's a nice way to go about it. I didn't see it myself. Okay. That's a limit we didn't study yet, but it says this over this equals 1. The limit is 1. But still, let's see what happens for half. Find values. It says part 3, but it's actually part 2, but whatever. It says here, but why? AN is decreasing. Why is AN decreasing from earlier? Where did it show? Where did you show? I think it's I think it skipped it. Where did you show prove AN is decreasing? You're right to be cautious here. Let's go back. Recall this equals that. That's approximation. That's completely false. You cannot have an approximation, say the way the approximation behaves, then the original behaves. Look that it does the same thing I wanted. It derives, but it derives a much simpler expression. It is meaningless. So yeah, we still have a leg ahead of ChatGPT. He's wrong here. Okay, is not able to prove it.
Can I ask a question?
Yes, Sammy.
Do we have to, in the question that we were answering, do we have to show that AN is decreasing? Do we have to prove that as well?
Yes, you must show it's decreasing. You
Right.
must know that it's decreasing.
Can we not just prove it by just plugging in a few values of N?
That's not a proof, Sammy.
But it's so obvious. But it's so obviously decreasing.
I completely disagree. We have an entire lesson when we saw that if we change a bit of the power, instead of n, it was n plus 1, the sequence switched from being increasing to decreasing. It's not obvious at all. Mass is not obvious. We have to prove such things. Otherwise, 9 is a prime number. Why? 3 is prime, 5 is prime, 7 is prime. Obviously, 9 is prime, right? We don't accept such proofs in mathematics. Okay.
Fine. So the way we prove it is by doing the gradient.
That's what I said. I think I didn't solve it until the end, but I'm pretty sure it will work. The study of the derivative, and that's also what ChatGPT did. But instead of deriving the complicated version, he did it on the approximated version. But the fact that the approximation is decreasing does not mean that the original is decreasing. That's mathematically false. So we must derive the original values.
And what we have to do is say that because the derivative is negative.
Yes, exactly.
Right.
And the reason I'm not doing it here is because we didn't learn how to derive it yet. After we will, and in general, analysis of functions, in order to know it's negative, we may need to use some theorems about analysis of function. I'm not sure. Thomas, I'm appointing you to remind me to study this very example in the future and making sure we know how to solve it. Okay, have a good one. Stay safe, guys, and I see you on Tuesday. I will email you as to what exactly will be the plan, but almost certainly it will be in Zoom. Bye-bye.
Right.